Hello class, welcome to week 7. We'll talk about some announcements here for this class, but I'll note that you are about halfway through, so good job on getting this far. Announcements-wise, so the Module 1 assignments, we have posted an example walkthrough video walking you through the code for the Aviation API example. So you can check that out. It's on the course webpage in Elms. There's now a second heading for code walkthroughs. We'll try and post one for every module here. For the Module 2 assignment, we're working on a walkthrough for the graphs code here, where you are given the IMDb movies dataset, and you want to extract or build a graph from that dataset where nodes represent movies and edges represent movies that share an actor or have an actor in common. So we're working on the walkthrough for that code now. I'll post it and post an announcement as soon as it's up and available. For assignment 3, so that is due this week, be working on that. We'll have a walkthrough for the code on the similarity assessment in this, hopefully next week. So you can see or walk through how we evaluated similarity between movies and their actors. This week starts the beginning of Module 4 on clustering. So now the assignment 4 is something you should be thinking about. This is due the 1st of April. I pushed the deadline back for this to give you some time after spring break. The main thing that this assignment is about is, given some data set, I want you to apply some clustering algorithm, one of the ones that we talk about this week or next, to your data, specifically where you identify and justify some value for k, where k is the number of clusters here, and then evaluate or describe what the clusters in your data represent. So in the IMDb dataset, maybe they're genres of films, maybe each cluster represents a genre or an international market, such as Hollywood or Bollywood, or maybe their ages or time frames. The IMDb dataset is from 2020 or movies from 2000 to 2020, so temporal information may not be a huge deal, but if you had looked at the full IMDb dataset, certainly there's going to be some breakdown where movies that were released recently are not going to have overlap in actors from movies that were released 40, 50, 60, 70 years ago. So once you've identified some interesting insight you want to extract from your data, figured out which clustering approach you want to apply, k-means or agglomerate clustering or something else, identify your value of k and justify why you chose that k. And then describe what each one of those clusters mean. So I'll have a walkthrough of the step-by-steps here in just a second. As with assignment 3, I'm not requiring you to collect your own data for this assignment. You're welcome to use data from Kaggle or some data that you've already collected or some data from your project. You're welcome to do that. And then, as with every other assignment, I want you to identify some non-obvious insight that's going to be actionable that you want to extract from your data. So specifically, you should be thinking about, as always, what decisions this insight might inform and how might you use those insights to take action. And then discuss what features you're going to use to determine similarity, which similarity metric is being used by your clustering approach. So k-means is primarily defined for Euclidean distance, but something like agglomerate clustering could use other distance metrics. So what did you do? Then discuss how you selected your k value. So that's going to be the crucial point. You need to say what your k value is and how you came to that conclusion. Did you say, well, I know that there's X number of political parties in this country, so I know that value should be k. I used some thresholding approach where we evaluated the silhouette score, we evaluated inertia. These are things I'll talk about next week to optimize for some value of k. How did you do that? It's crucial that you talk about where this value of k came from. Then I want you to describe and justify what you think each cluster represents. So are they topics? Are they genres? Are they markets? Are they political preferences? What have you? And then why do you think that? This is primarily going to be taking a few examples out of your clusters and inspecting them and showing them. And then these are all the standard sorts of things that you get points for. You should show some examples of the code you used to do this evaluation, what bugs did you encounter, good visualizations, and what are the major takeaways from your analysis. As we are evaluating the articles, we're taking points off if you don't include any code, because it's important that you show something about how you did this analysis. If you are one of those people who got points taken off for not showing code, by all means, if you put a code block in, you integrate that into your article, we'll give you those points back. So, what are the steps for this assignment? First, find data that's relevant and interesting to you and to your question or decision you want to make. This is a general step for all of your assignments. Read that data into Python, probably through pandas, like read CSV or something, or you could read it directly and using the .read function. This is, I think, what I do with the IMDb data. Convert that data into a matrix. If you want to use dimensionality reduction, you should explore that from the PCA or SVD examples from the previous module, because that will help you when you if you're trying to optimize a particular K value, this dimensionality reduction will help you, but it's not required. Select some reasonable value for K, explain why you came up with that value, using either domain information or the ELBO method. It's a thing we'll talk about next week. Apply your clustering algorithm, so you don't have to worry about re-implementing k-means or agglomerative clustering from scratch. The scikit-learn package has that, or has implementations for that for you. I encourage you to use those. There are good examples for that. And then for each one of the clusters that you identify, or at least for some subset of them if you have some really high value for k, pull out some samples, inspect them, describe what they represent or why they're similar, and give some sort of qualitative description for what you think each cluster represents. So that's how you'll get full points for assignment 4. As I mentioned, in sklearn there are examples and code for k-means or agglomerative clustering and many other clustering approaches available, so you can check that out. In Module 4, we're actually going to introduce this idea of machine learning, primarily around, or starting with the clustering aspect, and then not next module, but the module after, Module 6, is going to focus on supervised learning. This is classification and regression. We'll talk about these differences today. But if you look at scikit-learn, there's a nice cheat sheet for which algorithms you may use. And here we're in that bottom left case of clustering. And there are some examples or some decision points you can follow through this cheat sheet to figure out how you might apply the different clustering approaches that exist to your data. As I mentioned, there are a bunch of different clustering methods that sklearn supports. We'll talk primarily about agglomerative clustering and k-means, both of which are well implemented in sklearn. That's it for the assignments. Also, I should note all of your grades for assignment 2 are up. If you have submitted an assignment 2 article, you should have your grade for that. For the semester project, as I mentioned over the prior weeks, we've added a new assignment about engaging with the professor and the teaching assistant around your project. So specifically, there's this bi-weekly meetings assignment that's part of the semester project assignment. You are expected, or at least one representative of every team is expected to attend office hours at least every other week, where you give us like a 5-minute super brief overview of where you are, what you've done, any issues that you've encountered, to give us the opportunity to help guide you and provide you feedback so you don't end up being stuck with, I haven't made any good progress when your intermediate report is due in a few weeks, or you don't have any good progress when it comes time to do your presentation. If nobody from your team can come by office hours once every other week, please schedule a meeting with me. We can schedule office hours, or I can schedule a time away from office hours to meet up with you. The point is, we're trying to help you with your semester project, provide guidance where we can, so you don't stress out about how you're doing and not know where to go. So I encourage you, please come to this. Some of your groups have not come to any office hours yet. I want you to come to these office hours. It should be super brief, just to get some insight about where you are and how we can help you. Otherwise, your project proposals. So the project proposal revisions were due. This is from when I made these slides yesterday. The proposals were due. The revisions were due yesterday. That was the last day for you to get them in. If you have problems with that, please let me know. I've graded as many of them. I think I've graded a good number of them that have been submitted, but there are a few that I need to address. Your data collection report, that was due yesterday. I'll start reviewing those this weekend and get you insight back over the next week. Main thing here, the data collection report's a forcing function to make sure that you've collected some amount of data. So as long as you've got some amount of data and you answered some of these questions, you should be in good shape. If you need more time here, please let me know. Lastly, the next point of your, or the next touch point for your project is the intermediate report and review. So that's due in 4 weeks. I'll discuss what the details of the intermediate report are next week. While the proposal, the revisions, and the data collection report, I can be flexible with their deadlines. It's important that you get the intermediate report in on the assigned deadline day, because I will then share the intermediate report with your fellow students to get you feedback away from me, so you can see not just are you trying to convince me, but you're trying to convince your fellow students about the progress you've done and what's important about your work, or about the project you're working on. So we need to have those in on the appropriate day. This week, we're starting Module 4 on clustering and unsupervised learning. Module 4 will take across, or Module 4 will work across 2 weeks. So this week is going to focus on a few objectives. The first is this high-level objective, or this high-level differentiation between supervised and unsupervised machine learning. So first, what is machine learning, and how do we differentiate these two kinds of machine learning approaches? Then we'll talk about clustering, how clustering fits into the unsupervised case, and the different kinds of clustering that you may see. Primarily, there are 2 types of clustering: hierarchical clustering, where there's some hierarchy in the data that you're trying to extract, and then point assignment-based clustering. So k-means, the most popular clustering approach, is point assignment clustering. We'll talk about first this hierarchical clustering approach, what the 2 kinds are. So there's bottom-up and top-down. Then we'll talk about representations for clusters. And this is important because in the previous modules we talked about distance metrics. We can take 2 points and evaluate the distance or similarity between them. Here we want to be able to say, well, what if I have a cluster of multiple points? How do I represent that cluster so I can evaluate distances between a point and a cluster? Typical approaches are take an exemplar point from that cluster and treat that as the summary point, or take the average around points in that cluster to create a cluster center, but there are some issues with that we'll talk about. Then we'll talk about distances between clusters. There are a bunch of different metrics for evaluating distances between clusters. You might do distances between cluster centers, or the mean interpoint distance between all points in 2 clusters. There are a bunch of ways for this that we'll discuss. And then what are the conditions for stopping? Specifically in the hierarchical clustering case, where we're merging and breaking clusters to identify them, similar to what we did in the graph analysis case, how do we know when our clustering is good, or good enough to stop? This is a similar question that we examined in the Gervin-Newman method for community detection in graphs. This is a very similar approach here. Then in the next week, we're going to focus specifically on k-means, how we can use k-means to identify clusters, what k-means is doing, and what the different strategies might be for initializing clusters when we're talking about k-means, where we know beforehand we have some number of clusters k, and we want to figure out, well, what are reasonable initial selections for our clustering. And then how do we select the number of clusters? How do we select this value for k? So that point is particularly useful for the assignment for article. So that's it for an overview of where we're going in the next 2 weeks. I have some examples in GitHub that you can see for code associated with the clustering module. The first one is about hierarchical clustering. So we'll talk about, or we'll have code that shows how you can apply hierarchical clustering to the movie data. What this will do is look at, or given the recent movies data set that you've been providing, I've expanded this example a little bit to look just at US relevant titles. One thing that you'll see if you cluster across all the IMDb movies in the recent movies data set, the clusters that you get back are going to be something akin to international market. So if you want to look at something closer to genre, or like groups of actors in a particular market, I've provided some code to let you filter just on titles that have been released in the United States, or that were their primary country of release was the United States. That lets us reduce the amount of data a good bit. And then we can construct a matrix of movies and actors. So movies are the elements and the actors are the features. I have code that builds this using a sparse matrix, so we can do this using a large data set. Then I want you to choose some value for k. Here in the hierarchical clustering case, I will have an example about where you might use or extract k from the hierarchy. But for now, you can just select some k that you think is reasonable, and then apply agglomerative clustering from sklearn to this matrix. So agglomerative clustering is a class. It's a clustering approach that we'll talk about this week in part one of the clustering module. That is a hierarchical clustering approach that combines clusters or builds these clusters up. And then once we've identified these clusters, I have some example code that will pull out some movies from each one of these clusters and show you the actors and genres associated with them, so you can get some sense of what these clusters represent. Then next week, I'll have an additional exercise that uses k-means, but the code for that is already up. If you want to look at the code for the hierarchical clustering approach, that's in GitHub now. I'll have the exercise for k-means. The code is already there. But next week, when we talk about k-means, I'll have the exercise for that up as well. For next week, so for this week, hopefully you have read the first few sections of Chapter 7 of MMDS, because that sort of sets the tone for what we're doing with clustering. But also, as we move into machine learning, we now have some reading assignments from IMLP, the Introduction to Machine Learning with Python book. Well, first off, I want you to read the first 7 pages of that. Sort of sets up the foundation for machine learning, not just the data mining approaches that MMDS has been focused on. And then I want you to read Chapter 3, the first couple of pages around unsupervised learning, and then the clustering descriptions for k-means and agglomerative clustering. So IMLP is going to be a good resource that'll show you how some of this work is done, because IMLP has examples or code blocks for each one of these pieces, so you can see or follow along with their code. Crucially, here in Chapter 1, you'll see one of the things that Mueller and Guido talk about is the importance of knowing your data and how your data is going to be used. So when I keep pushing you on understand what your task is, what the decision you're trying to inform is with the insights that you're extracting from your data, it's that kind of thing. It's important. It's like even here in this textbook, it's crucially important that you know what the context of your data mining or machine learning task is. That's it, though. That's it for this week. I encourage you to check out the lecture for clustering to get a sense for that, and come by office hours if you have any questions.